Hello everyone. Today in this session we are going to discuss regarding the water supply appurtenances. So in the water supply system there are many fittings are involved or which are in terms of various valves are there or check valves are there or any regulating valves are there. So many things are which are associated as a appurtenances. So today's session especially uh, especially dedicated for discussing all these water supply appurtenances. So the different devices required for controlling the flow of water for preventing leakage and other purposes in water supply system are called as appurtenances. The distribution pipes are provided with various pipe appurtenances and accessories so as to make the distribution of water easy and effective. What is the necessity of the water supply appurtenances? The main purpose of water supply appurtenances is to make the distribution of water easy and effective, to avoid the wastage and leakage of water, to change the direction of flow of water in pipeline, to make the efficient use of water, to control the flow of water in opposite direction in pipe, to regulate the flow of water. What are the various requirements of a water supply appurtenances? It should be strong, it should be durable, it should be economical, it should have resistance to corrosion, it should have resistance to internal pressure of water, it should be easy to remove and repair, it should not be affected by chemicals and acids. Now let's discuss regarding the valves. Valves are mechanical devices that controls the flow and the pressure within the system or process. In waterworks practice, to control the flow of water, to regulate the pressure, to release or admit the air, prevent flow of water in opposite directions, the valves are used or required. Functions of the valves are stopping and starting the flow, reduce or increase a flow, controlling the direction of flow, regulating a flow or process pressure, relief of a pipe system of a certain pressure. Types of valve. Depending upon different situation and requirements, different types of valves are used in the supply system. First one is a sluice valve, which is also called as a stop valve. Second, check valve, which is also called as a reflux valve. Air relief valve, which is also called as a float valve. Drain valve, which is also those are also referred to as blow offs. Zero velocity valve, scour valve, ball valve, and fire hydrant. What is sluice valve or stop valve? So you can observe here this wheel you can observe here, and the water, this particular is you can say fixed between the two pipelines which are carrying the water through that particular mechanism. So you can see this may be inlet or this may be outlet, or also you can say the water regulates, or you can say sometimes these are also called as a gate valves. So this is generally used to control the flow of water in the pipeline. When a question of repair is needed, this valve close the supply water beyond the wall in the pipeline. This is made of cast iron having a brass or stainless steel mounting at its end fitted with a pipe. A circular wedge shaped disc is attached to the end of a threaded spindle or stem passing through a gland. This is connected to a handle by means of a threaded spindle. This can be used to control or regulate the flow. Sluice valve or stop valve. These valves are cheaper, offer less resistance to the flow of water, than other walls. The entire water supply system is divided into blocks by providing these walls at appropriate places. They are provided in a straight pipeline at 150 to 200-meter intervals. When two pipelines intersect, the walls are fixed in both sides of intersection. For long straight mains, the slit piles can be installed at a distance of about 1 kilometer, also to divide the pipeline in different sections. So you can see, you can observe this particular handle. This is a spindle, and this is the wall, you can see. So which can be used to regulate. Check wall. This is sometimes called a non-return wall. A reflux valve is an automatic device which allows water to go one direction only. The swing type of reflux valve is widely used in the practice. When water moves in the direction of arrow, the valve swings or rotates around the pivot and is kept in open position due to the pressure of water. When the water flow of, or you can say flow of water in this direction ceases, the water tries to flow in a backward direction, but this valve prevents the passage of water in the reverse direction. So you can see here the arrows have been shown here. This is the flow of water. So when the flow takes place, in that it opens, remember it is, but when flow stops, this valve you can see it is closed, and the water from this side will not be allowed to enter here. So this is a non-return valve. Now you can observe here the types of check valve, where the first figure, or you can say this particular isometric view have been shown of a swing valve, and another view have been shown as the lift valve. So only the mechanism is there, that how the water will be trapped or controlled. So that is the mechanism. In this case, in first case, it is by using the swing mechanism. So this valve gets swings because of pressure of water, and lift is observed here in case of the vertical movement is observed in case of the lift check valve. Air relief valve or float valve. So in a longer pipeline, air accumulates at high points of the pipeline, which interfaces with stream flow of water. At such points, air valves are provided which remove the accumulated air automatically. This valve has one or two hollow float chambers. There are air opening at the top, and the valves are connected to the main as shown in the figure. Float chamber normally remains full of water. When air fills it, the water level goes down and the float falls, thereby opening the air or air openings at the top through which the air escapes out, after which the chamber again fills with water and takes up the float up, which closes the air opening. So here you can observe this, the water pipe is there. So this is the float chamber. The poppet valve is provided also here. You can observe the float. Okay, so the action takes place when how the pressure is applied on this. So as in this particular chamber, when the air fills in it, the water level goes down. This is full of water. Water level goes down, and the float comes down, and because of the opening, you can see the air opening at the top, which releases this air which is trapped. So here you can see the view of that air relief valve, or which is a float valve. So that air valve consists of a cast iron chamber. So this is the forming of a cast iron chamber, float, a lever, and the poppet wall here. The chamber may be circular or rectangular in shape, and the poppet wall is a wall that lifted bodily, can say. So this releases the air, and depending upon the how the air is entrapped in this particular wall. Now the various different walls which are generally used in the pipeline: drain wall, or these are also called as a blow hops. So these are also called as a washout walls. They are provided at all dead ends and depression of pipelines to drain out the wastewater. These are ordinary walls operated by hand. So you can see this handle is provided. Zero velocity wall. The zero velocity wall called as a water hammer arrestor. The principle behind the design of this wall is to arrest the forward moving water column at zero momentum. That is when its velocity is zero and becomes any return velocity is established. What are the advantages of the zero velocity wall? Controlling the closing characteristics, low loss of head due to streamlined design. So the figure shows here the zero velocity wall. So whenever, in case of water pipeline, whenever the water stops, the hammer is observed, and to compensate such particular water hammers, this zero velocity wall has been designed, and which arrests that particular hammer which is observed. Scour wall. These are similar to the blow up walls. They are ordinary walls operated by hand. It is placed at every depression in the pipeline. Mud and sludge get collected in the pipeline at these depressions, which generally occur when pipe cross valleys, etc. The wall is essentially mounted on a branch of the main pipeline at the lowest point. The wall is worked. It removes the dirt due to the high velocity of water. After the complete removal of silt, the wall is closed. Okay, so this is especially mounted. This particular type of wall is mounted. Wall is mounted at the lowest elevation to remove the silt and whatever the dirt present in the pipeline. Ball wall. So this is known to us that a ball wall is a cotton turn rotational motion wall that uses a ball shaped disc to stop or start the flow. If the wall is open, the ball rotates to a point where a hole through the wall is in the line with the wall body inlet and outlet. If the wall is closed, the ball is rotated so that the hole is perpendicular to the flow opening of the wall body and the flow stops. Now you can see, observe here, this is the pipeline and this is the ball which is provided with this opening or hole, you can say. So when you want the flow of water, so you can say this will be exactly in the direction of the water, and when you want to close that, so this side, that will be exactly perpendicular to the flow of water, so which ceases the flow. Fire hydrant. Hydrant is an outlet provided in the water pipe for tapping water, mainly in case of fire. They are located at the 100 to 150 meter apart the roads and also at junction roads. There are two types of namely these as a fire flush hydrant and a post hydrant. So you can observe here one fire hydrant. You can see here a water pipeline, the wall is provided. So if you are releasing the wall because of the pressure, okay, so this is the outlet. So in case of the fire hazard, so the water can be utilized. Now what are the requirements of good hydrant? It should be cheap, it should be easy to connect with the hose or motor pump, easily detachable and reliable. It should function properly and should not go out of order during the operation. It should permit undisturbed flow of water when being fully discharged. Water meter, that we know that to determine the quantity of water flowing through the water meters are installed. The readings obtained from the meter helps to working out the quantity of water supplied, and thus the consumers can charge accordingly. The water meters are usually installed to supply water to houses, industries, hotels, big institutions, etc. Metering prevents the wastage of purified water. Now, what are the requirements of a good meter? It should not offer any resistance to the flow of water. It should measure the discharge up to 2% accuracy. All its parts should be of non-corrosive alloy. It can be easily maintained and repaired. It should be economical. It should have screen on its inlet side to exclude the clay, silt, grit, etc. It should be capable of registering even small quantity of flow of water. And also again there are various types of water meters are there. Generally, first one is a positive displacement type of water meters and velocity meter. That depends upon how the mechanism is used in the water meter. Storage tanks, that we have already discussed. Storage tanks may be kept on the roof of the building or on the ground, or should be watertight. The storage tank should be placed in such a position so that discharge of water can be readily seen. The tank should be provided with overflow pipe and drain pipe near the bottom of the clean tank, and the storage tanks are provided with the outlet pipe to draw the water. So these are generally where the user's end, you can say, this storage you can say tanks are used. Okay, where the supply pipe you can observe and outlet you can observe, the drain pipe in case of the removal of the silt, and this is the overflow pipe. Okay, if the float is provided there, so it stops the flow automatically, entry of the flow of water in the storage tank. So also you can see the storage tanks here also. So these storage tanks are the small tanks installed above the roof level and being supported by a strong base, right? Bibcock, these are the water taps which are attached at the end of the water pipes, and from which consumer obtain the water. Bibcocks are available of various patterns. Now these particular figures you can see, which is a typical bibcock. It is operated from a handle, and when handle is turned, the opening from which the water comes out gets increased in size, and the bibcock may be also a push, and they operate automatically. They open out with a with a slight push is given, and it close down as soon as the push is removed or withdrawn. Okay, so here you can see the spindle is provided, so the water comes from here, right? So when the valve is closed, this particular bottom of this particular wall, this is a rubber is here, or you can say, so which close this particular opening, and the water is stopped. So here the view of the a bibcock is there. The leaky bibcocks are source of waste of water. The various you can say various efforts you must take to avoid the leakages of water. So it is therefore advisable that to repair and replace such leaky bibcocks as soon as possible. Stopcock. So you can see a flow of water is you can see here. So this particular, it is a you can see this stream of spindle is provided here in the same way. So this is the wall which closes this particular opening. So these are small size sluice walls, and they are installed in a service pipes serving the bibcocks. They operate on the same principle of a sluice wall, and they are used up to sizes of 50 mm. They are placed on the water pipe leading to the flushing tanks, wash basins, and water tanks. It should be of a size sufficient to pass the required discharge through the service pipe. Stopcock. It is provided before the water meter service line. The stopcock is housed in a suitable masonry chamber with a removable cover, and is fixed in the street close to the boundary wall in an accessible position. It controls the supply of water to the building from the water main. The purpose of stopcock is to stop the supply of water. The temporary disconnections are made at the stopcock, while these permanent disconnections are made at the ferrule. So this total, you can say, this is connected to the pipeline, and totally it is used for the stopping the flow. So again, there are several minor appurtenances are there, which are used in the pipe distribution system, or in the water connections, or so in the to regulate the flow, to stop the flow, to deviate the flow. So thank you very much for joining the today's session.